Hello everyone and welcome to another exciting segment of Math with Miss Bennett. Today we're talking about mean absolute deviation, which is the average distance of the data values from the mean. It sounds like it's really big and terrible, but it's actually not that bad. There are 3 simple steps. Step 1, find the mean. Step 2, find the positive difference between the mean and each value. And then step 3, the final step, find the average of the differences. And there you have it. You can calculate the mean absolute deviation. None of those steps are hard, they just take a lot of effort. I highly encourage that you use a calculator to simplify the process. So here's our data set. Our data set is the height in inches of children in a neighborhood. We have 52, 59, 48, 54, 60, 58, 55, and 62 inches. For step 1, we're going to find the mean of our data. So we're going to add them all up. To find the mean, we need to add up all the data and divide by how many there are, which is 8. The total of our data is 448. 448 divided by 8 is 56. So the mean of our data is 56 inches. Here I've placed the data in a dot plot. This step is optional, but it simply helps some people see better. I'm going to mark the median of 56 with a line, a dotted line. All right, so looking at this, we can see that we've drawn a dot plot, and we're going to find the distance, literally, of the data values from the mean. So my first data value is 52, and if I count it, the distance is 1, 2, 3, 4 away from the mean. 59, which is 1, 2, 3 away from the mean. 48, which is 1, 2, 3, 4, 5, 6, 7, 8 away from the mean. 54, which is 1, 2 away from the mean. 60, which is 1, 2, 3, 4 away from the mean. 58, which is 1, 2 away from the mean. 55, which is just 1 away from the mean. And 62, which is 1, 2, 3, 4, 5, 6 away from the mean. What we have here are the distances from the mean. Now, you wouldn't always want to draw a dot plot to find this, so you can use differences and take the absolute value of each difference, or just make each difference positive. Here you can see, as I did each subtraction, the mean is in red. I swapped the order of the subtraction so that the answer would come out positive, so that the bigger number had the smaller number subtracted from it. Again, we're looking at mean absolute deviation. It's all about distances, which is absolute value, so it always has to come out positive. Now we're going to do the last step, which is finding the average difference. We need to add 4 plus 3 plus 8 plus 2 plus 4 plus 2 plus 1 plus 6. And divide that sum by 8 because there's 8 differences. The sum is 30, and when you divide 30 by 8, you get a MAD, or mean absolute deviation, of 3.75 inches. This tells us that overall, there is not a lot of variation in this data as it relates to the mean. The average child is only 3.75 inches away in height from the mean height. For the sake of clarity, we're going to try one more example. As we go through this example, I encourage you to pause at the times I mention it and try it yourself. So with our data set, we have the data 1, 2, 2, 3, 5, 7, 7, 7, 7, 9. I want you to pause and find the mean of this data set. The total of the numbers is 50, and 50 divided by 10 values is 5. So the mean of the data set is 5. Actually, let's not box that because that's not our final answer. Now we're going to calculate the differences. What I've done here is create a table, my personal favorite method to organize finding the differences for the data. Pause, take a moment, and find all the differences for this data. The difference of 5 and 1 is 4. The difference of 5 and 2 is 3. And then 3 again. The difference of 5 and 3 is 2. Make sure you're keeping these differences positive. The difference between 5 and 5 is 0. It's perfectly okay to have a data value that's equal to the mean. Its difference will be 0. These differences are 2. And this difference is 4. Now you need to find the average difference. Pause the video and take a minute to find the average difference. The total of the differences is 24. Divide 24 by the number of differences. 24 divided by 10 is 2.4. So the MAD, or the mean absolute deviation, of this data set is 2.4. This MAD tells us that this data set is relatively consistently packed around its mean. So there's not a lot of variation amongst the data values and the mean. I hope that this video has helped you better understand mean absolute deviation. It's simply the average distance or difference of data values from the mean. The steps are simple. You find the mean, you find the differences between the data values and the mean, and you average up those differences. This is a measure that measures spread or variation. It tells us if our data set is consistent, tightly packed, or spread out, and more varied. I hope that this helps. This has been an exciting segment of Math with Miss Bennett.